OpenAI isn't just making chatbots anymore. And honestly, that framing is starting to miss the point. What's happening right now looks less like a company shipping new features and more like a slow, deliberate attempt to rebuild the physical foundation of AI itself. This started as a cloud-first organization, living entirely in servers and APIs, scaling language models upward until the limits became unavoidable. Compute costs exploded, latency mattered, and the gap between intelligence on a screen and intelligence in the real world became painfully obvious. Once you hit that ceiling, you either stop or you move into hardware. And OpenAI is moving fast. For years, the question was, what can ChatGPT answer? Now the question has shifted to something much bigger. What happens when the same intelligence can see, hear, move, and physically act around you? That question explains almost every move OpenAI has made recently, from manufacturing partnerships to robotics hires to trillion-dollar infrastructure ambitions. Not long ago, OpenAI quietly sent out requests for proposals to U.S. hardware manufacturers, and the scope of what they asked for says everything. Chips, motors, packaging materials, advanced data center cooling systems, all from domestic suppliers capable of manufacturing at scale inside the United States. That's not a side project. That aligns directly with the Trump administration's push to reshore manufacturing and rebuild American supply chains, effectively turning AI into a lever for reindustrialization rather than just another cloud expense. OpenAI's Chief Global Affairs Officer, Chris Lehane, has openly framed AI this way, arguing that while China still dominates hardware manufacturing, the U.S. may hold the edge in building the brains of machine intelligence. Policy, hardware, and software are now fused into one strategy. Behind those RFPs is a capital plan that almost sounds fictional until you look at the details. OpenAI has said it intends to invest trillions of dollars into expanding data center capacity. The centerpiece of that vision is the Stargate project, a roughly $500 billion plan with partners like Oracle to build massive US-based AI infrastructure over 4 years. Stargate isn't just server racks. It's custom silicon, advanced cooling, localized manufacturing, and a physical footprint that anchors frontier AI on American soil. The scale matters because only a handful of organizations on Earth can even attempt something like this, and OpenAI is clearly positioning itself as one of them. Cooling, interestingly, has become one of the quiet pressure points in this race. OpenAI's proposals put heavy emphasis on next-generation cooling solutions because each new model generation demands denser, hotter compute packed into smaller spaces. At the same time, NVIDIA CEO Jensen Huang has publicly suggested that upcoming Rubin chips may not need traditional cooling equipment at all, a comment that immediately rattled cooling manufacturers' stock prices. So you have OpenAI aggressively searching for better cooling, while the dominant chip supplier hints that cooling itself may be disrupted at the silicon level. Infrastructure assumptions are breaking in real time. But this isn't just about data centers buried under deserts or humming on industrial campuses. It's also about robots. Lehane has said outright that OpenAI's interest in robotics is deeper than most people realize, and that the industry will move faster than expected. That confidence became concrete in September 2025, when reports revealed OpenAI had formed a new humanoid robotics team and began hiring researchers specializing in control algorithms, teleoperation, and simulation. The language in those job postings was unmistakable: general-purpose robotics, AGI-level intelligence, and deployment in dynamic real-world environments. One detail from those postings really gives the game away. A mechanical engineering role required experience designing systems intended for production runs exceeding 1 million units. That's not a lab prototype. That's mass manufacturing. When OpenAI starts talking about million-unit mechanical systems, it's signaling a future where AI isn't something you access. It's something that gets deployed at scale. Humanoid robots sharing a common AI brain, born in the cloud and distributed across warehouses, homes, and city streets, suddenly stop sounding far-fetched. This is the same company that shut down its robotics division in 2021, now re-entering the field directly alongside Tesla, Google, and Figure. At the same time, OpenAI has been building the other end of the pipeline, consumer hardware. In May 2025, it acquired the AI device startup I.O., co-founded by Jony Ive, the designer behind the iPhone. By July, that acquisition was finalized. Then in November, OpenAI announced a partnership with Foxconn to design and manufacture next-generation AI hardware inside the United States. According to multiple reports, Foxconn has already secured orders from OpenAI covering both AI servers and endpoint devices, making it the first contract manufacturer to span OpenAI's entire ecosystem. This isn't about a single gadget. It's a vertically integrated stack from data center to pocket. The first product from that effort is already taking shape. Taiwanese media report that OpenAI's initial AI hardware will be built exclusively by Foxconn and is expected to launch in 2026 or 2027 under the internal codename Gumdrop. Designed by Jony Ive, the device is believed to be either an intelligent pen or a wearable audio product, roughly the size of an iPod shuffle. It reportedly includes a microphone and camera, can transcribe handwritten notes, upload them to ChatGPT in real time, and process information on the fly. Sam Altman has described it as simple, beautiful, and fun, but the real story is the direct, always-on link to OpenAI's most advanced models. And Gumdrop isn't the endgame. Reports point to an entire family of screenless devices on the roadmap, including smart glasses and smart speakers, positioned as collaborative companions rather than tools. Ive has argued that removing the screen isn't just more natural, it actively avoids the addictive behaviors that touchscreen devices trained into users over the past decade. If that vision holds, AI stops being something you stare at and becomes something that listens, speaks, and occasionally sees, embedded into your environment. The same intelligence powered by Stargate-scale infrastructure suddenly lives in your ear and on your desk. For that to work, the voice layer has to catch up. Inside OpenAI, engineering, product, and research teams have reportedly been merged over the past 2 months to tackle audio interaction as a single problem. Internal researchers believe the current voice model lags behind text in accuracy and latency, which simply doesn't work if spoken language becomes the primary interface. A new voice model is in development with more natural emotional expression, real-time responsiveness, and the ability to handle interruptions mid-conversation, with a target release in the first quarter of 2026. Step back and look at 2025 as a whole, and the pattern is hard to ignore. A $38 billion server agreement with Amazon, a $6.5 billion acquisition of Jony Ive's design team, Foxconn locked in for servers and devices, a $500 billion infrastructure vision, a reboot of humanoid robotics with mass production in mind, and a deliberate shift toward US-based manufacturing in a politically favorable environment. Every move reduces dependence on Microsoft and pushes OpenAI toward owning the brain, the body, and the pipes of the next machine age. The age of AI that just talks is ending.